Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subjects. Today in our unit Electric Circuit of class 12th Physics, we'll study in next 5 minutes the concept of superconductivity and describe applications of superconductivity so that you can answer usual questions asked in our examination. Let's start. During study of mercury in cryogenic temperature conditions, Onus first observed in the year 1911 that when temperature is gradually reduced, the resistance which is decreasing all of a sudden becomes zero at 4.2 Kelvin conditions. This phenomena observed by Onus in mercury at critical temperature 4.2 Kelvin where resistance of mercury becomes zero is known as superconductivity, and it is found that few other metals and composite materials at some specific low critical temperature show an abrupt decrease in their resistivity to zero value. Later it was observed that niobium show the same zero resistance condition or superconductivity at a critical temperature of 9.2 Kelvin, whereas a rare earth composite material, yttrium, barium, copper oxide, show this superconductivity conditions at a relatively high temperature of around 92 Kelvin, and such yttrium, barium, copper oxide type of materials are also known as high temperature superconductors. It is really strange that the best conductor, silver, copper or aluminum, never become superconductor at any low temperature conditions, whereas these ceramic composite like yttrium, barium, copper oxide, which are superconductor at relatively high temperature, are not good conductor at room temperature conditions. At very low cryogenic temperature condition, when a material achieves superconductivity state, then it possesses free electron conditions, but the random thermal motion of these free electrons cease, and the movement of electrons no longer remain independent, but they become mutually dependent and coherent, and all free electrons will move in the same direction with same velocity without collision, and without collision such material in superconductivity state show zero resistance conditions. So in superconductor material at critical temperature, the thermal motion of free electron cease, and without collision the movement of electron become coherent and resistanceless. Another strange behavior of superconductor is observed by Meissner, and in superconductivity state, the magnetic field inside the superconductor becomes zero. In fact, a superconductor behaves like a perfect diamagnetic material and won't allow external magnetic force lines through it. And when a superconductor material is placed in magnetic field, its induced behavior in superconductor material generate an equal and opposite magnetic effect inside the material, and external magnetic field can't penetrate material, and in these conditions a superconductor material induce opposite pole effect adjacent to applied magnetic field, and there exists a mutual repulsion, and such superconductor material in perfect diamagnetic state can leviate near a magnetic field, and we can use this phenomena for leviated train traction applications and can have a energy efficient transportation system if such leviated train possibilities which exist in laboratory condition become a ground reality. In last 3 decades, superconductivity is a very interesting field of research all over the world, and scientists have been working actively to prepare such superconductor material which can work in room temperature conditions, but unfortunately till date we met with only marginal success, and high temperature superconductor also need a very low temperature condition, and to maintain those critical temperature conditions it involves lot of amount of investment which won't make superconductivity experience economic viable and technically feasible in general practices. But if superconductivity become economically viable and technically feasible, then there could be several applications we can see ahead. Superconductor can be used to produce very strong electromagnets, as current can pass through superconductor without any investment, and we can circulate huge amount of current in coils to produce a very strong magnetic field that can be used in several applications. applications. Now, superconductivity can play an important role in material science research, and it can be used to invent new material. And accelerated particles in strong magnetic field can produce collisions and new observations if superconductivity is used in high energy particle physics studies. Now, superconductivity can be used in our modern high speed computers that can increase both computational speed and other capabilities. We can also use superconductor in our conventional electric power transmission wires and without resistance. When power is transmitted from faraway generating plants to consumers, we could have lossless energy efficient power transmission of electricity through superconductor wires. In this small and informative video, in just 5 minutes, we have explained the concept of superconductivity and described various applications of superconductivity to fulfill your class 12th physics examination requirement. We hope you found this work valuable. Do share it with your friends. Happy learning. Thank you very much.